Imagine embarking on a journey unlike any other, a mission that stands as one of humanity's greatest adventures, the Voyager missions. In 1977, Voyager 1 and 2 launched as our robotic pioneers tasked with exploring the outer planets, Jupiter, Saturn, Uranus, and Neptune. They seized a rare planetary alignment, a unique opportunity that comes only once in a lifetime. These spacecraft weren't just on a sightseeing tour. They returned images and data that revolutionized our knowledge of distant planets and their moons. The Voyagers are more than just machines. They symbolize human creativity and our relentless drive to explore. Each probe carries a golden record, a time capsule filled with sounds and images from Earth, intended for any intelligent beings who might discover them. It's our message in a bottle, drifting through the cosmos. We existed. This is our story. After their planetary tour, the Voyagers ventured into interstellar space, becoming the first human-made objects to cross the heliopause, the boundary of our sun's reach. As of July 22, 2025, these trailblazers are still out there, billions of miles from Earth, expanding the frontiers of our knowledge. They embody our highest ambitions, the urge to discover what lies beyond, even if beyond is a light year away. The Voyagers are a physical manifestation of our curiosity, carrying our story into the galaxy. They remind us that we're part of a vast universe, far greater than our tiny home. And as we'll discover, their ability to astonish us is far from finished. Their mission didn't stop at the planets. It became a quest for the stars. They are our scouts, venturing into realms we've only dreamed of. The information they send continues to reshape our understanding of the cosmos. The Voyager legacy is still unfolding. How is it possible that we're still in contact with these distant probes, launched back when disco ruled the airwaves? The secret lies in ingenious design and the power of nuclear energy. Voyager's radioisotope. Thermoelectric generators, or RTGs, convert heat from decaying plutonium into electricity. Unlike solar panels, RTGs deliver consistent power, even in the pitch-black reaches beyond our solar system. As the plutonium slowly fades, the available power drops, so engineers have powered down non-essential systems to keep vital instruments alive. The signals Voyager transmits are astonishingly weak. Imagine the glow of a fridge bulb spread across the entire planet. To catch these faint messages, we rely on the Deep Space Network's enormous antennas, listening for whispers from the solar system's edge. Voyager's transmissions are our only direct window into the magnetic fields, cosmic rays, and plasma of interstellar space. Every bit of data is invaluable, a rare postcard sent from the frontier of the unknown. Communicating takes time, almost a full day for a signal to travel there and back. This isn't a live conversation, but a patient dialogue across a vast cosmic distance. Still, Voyager stands as one of humanity's most valuable scientific tools. It's a tribute to the visionaries who crafted a spacecraft that surpassed even their boldest dreams. Voyager keeps sending us discoveries from the vast unknown. To truly understand Voyager's journey, you need to imagine just how vast space really is. Our solar system sits inside a small bubble called the heliosphere, shaped by the solar wind. The boundary of this bubble, the heliopause, is where Voyager 1 and 2 have ventured into genuine interstellar space. Beyond that, space isn't empty at all. It's filled with a thin mix of plasma, neutral atoms, dust, and cosmic rays. Voyager's instruments sample this environment, acting as cosmic sentinels, detecting the interstellar winds and radiation. They're giving us the first direct readings of density, temperature, and magnetic fields outside our solar system. Most of the time, this region is expected to be calm, a steady background of cosmic rays and magnetic fields. The probes chart the interstellar weather, helping us understand what's typical out there. With their cameras shut down, Voyager's mission now is to sense, not to see. The discoveries are often subtle, slow patterns and gradual changes, rather than sudden events. But when something disrupts that steady pattern, it grabs everyone's attention. Voyager's constant flow of data is our lifeline to the mysteries beyond. This is a science of patience, waiting for the cosmos to share its secrets. And every so often, something truly unexpected appears. That's exactly what unfolded. Voyager picked up something entirely unexpected. Within the steady stream of routine data, a faint but persistent irregularity emerged. Initially, it seemed like a technical hiccup, but backup systems confirmed the reading. Voyager had detected movement. This wasn't just random plasma or cosmic rays, it was a distinct object, following a path. Voyager now travels far past Neptune, where our sun is nothing more than a distant point of light. All known planets are far behind, and the closest star system is still over 4 light-years away. What Voyager detected was a moving object adrift in the immense space between stars, an interstellar wanderer. Until now, we believed the void between stars was nearly empty of large, solid bodies. We've witnessed interstellar visitors like Oumuamua and Borisov passing through our solar system, but Voyager found one out in the wild. This hints that the galaxy could be full of wandering objects, rogue planets, asteroids, or comets, silently drifting for ages. Voyager didn't capture an image. Instead, it sensed the object's effect on its surroundings. It's like a ghost in the data, a subtle signal revealing something real moving through the darkness. The consequences are astonishing. The galaxy may be crowded with these cosmic exiles from distant stars. Voyager's find marks a major leap in how we understand the interstellar medium. It's proof that even in the loneliest stretches of space, the universe still holds surprises. And this is only the beginning. So, with its cameras long dormant, how did Voyager manage to notice something moving out there? The secret is in its other tools, like the plasma science experiment, the cosmic ray subsystem, and the magnetometer. These devices track the flow and density of charged particles, the energy of cosmic rays, and shifts in the magnetic field. For a long time, the data was steady, until a faint disturbance rippled through the plasma readings, like a pebble tossed into calm water. Something was nudging or pulling the plasma, hinting at a gravitational or magnetic force at play. Next, the magnetometer picked up a sudden twist in the magnetic field, a clear sign that space itself was being disturbed. Then, the cosmic ray subsystem registered a dip, as if something had cast a shadow and blocked the rays. By carefully studying when and how long these changes lasted, scientists could deduce the object's size, speed, and path. There was no photograph, but a detailed profile emerged from these environmental clues. It was a brilliant feat of interstellar investigation. So, what exactly did Voyager find out there? The leading theory points to a rogue comet or asteroid, an object ejected from its original system billions of years in the past. There's also the possibility it's something much bigger, like a rogue planet or a sub-brown dwarf. Huge, cold bodies silently roaming the galaxy. Detecting such an object by its gravitational effects would be a groundbreaking achievement, reshaping our understanding of what populates our galaxy. Of course, there are even more speculative ideas. Perhaps it's a shard from a catastrophic planetary collision, or maybe a relic from the galaxy's earliest days. Voyager's instruments reveal its size and path, but its makeup, whether icy, rocky, or metallic, remains a mystery. This uncertainty is both tantalizing and maddening, sparking fresh ideas and hypotheses. While the notion of it being artificial is highly unlikely, scientists remain open to all possibilities. For now, the natural explanations are already captivating in their own right. A single reading from this decades-old spacecraft could reshape how we view our galaxy. If interstellar space is crowded with wandering objects, the galaxy holds much more material than we ever imagined. This discovery backs up theories that suggest countless worlds are flung into the void during planet formation. Our galaxy might be teeming with orphaned worlds, each with its own untold history. Some of these objects could even be cosmic messengers, spreading life or organic material from one star system to another. For future missions, this changes everything. Interstellar travel could be riskier, but these objects might also serve as waypoints for explorers. They're no longer just hypothetical, they're real places we can aim for. Thanks to Voyager, what once seemed like science fiction is now a real engineering challenge. This finding gives us a new perspective on our position in the galaxy. The mysteries of the cosmos just became a bit more tangible. Each new discovery solves a mystery, but sparks countless new questions. Just how many more of these strange objects might be out there? Was Voyager's detection a rare coincidence, or just the beginning of many more to come? This challenges us to rethink our own solar system. Could some far-off Kuiper Belt objects actually be visitors from other stars? Every interstellar wanderer is like a message in a bottle, carrying stories from distant worlds across the galaxy. Voyager shows us that the universe is alive, ever-changing, and always ready to surprise us. It inspires us to ask bigger questions and imagine what comes next. The space between the stars isn't just emptiness. It's an unexplored frontier, waiting for discovery. And after all these years, Voyager has offered us our first thrilling peek into the unknown.